Alright, in this video we're going to look at radicals that have rational exponents. All that means is when you have a rational exponent, you would, in the exponent part, you'll have a fraction, so like basically a over b. We need to know that a x to the power of a over b is the same thing as the root would be b, then the denominator x, and then a. Okay, so these two are saying the same thing. Just make sure that the root is down here. That's a b, not a 6. Okay, so here's just a example. Let's say that I have 2 to the power of 3 over 4. I can rewrite this as fourth root of 2 to the power of 3. Okay, you do need to know this part. So here it says select 3 equivalent values. So honestly, I would, since they don't have variables or anything, I could just put each one in Desmos and see. Equivalent just means equal, so I can go ahead and put this, all this in Desmos. So cube root is 64. Okay, and then you have 32, which is just 32. 64 to the power of 1/2. 1/2. 4 is just 4. And then 64 to the power of 1/3. So looks like the 3 equivalent ones is this one. Cube root of 64 is 4. 4 is equal to 4, and then 64 to the power of 1/3. So anyway, that's what this one is. Cube root of 64 is equal to 4. And then this one right here, remember, it's just 64 to the power of, this is my root. And there's an exponent of 1, so that's 1/3. That's the reason why they're both, these two are equivalent. But I would just put everything in Desmos. Sorry, okay, next one. Amparo discovered a pattern when working with exponents. So it looks here, when you have the same base, you can add the exponents. So 5 plus 11 is 16. Same thing here, negative 4 cubed times negative 4 to the 4th, same base. Then 3 plus 4 is 7. Okay, so look, 5 plus 11 is the 16. That's where this 16 came from. 3 plus 4, as long as they have the same base, you can do this. And then they all have the same base of 2, so this is 3 plus 4 plus 5 is 12. That's what that pattern is. So based on the pattern, what would Amparo select as an answer for this? So they all have the same base of b, and then here you have, make sure that you see that there's a 1 here. So this is 5 plus 1 plus c, b to the power of 5 plus 1 plus c. So 5 plus 1 is 6 plus c. That's the answer right there. Couple more here. So what is this expression simplified? As a simplified rational exponent expression. Okay, so basically I don't want any radicals in here. So to simplify this, what I'm going to do is I'm going to go ahead and kind of simplify underneath the radical and then see what else I can do. So you have here 63 divided by 7 first, so which is 9. So the radical doesn't go away yet, so I'm just going to put 9. And then here I can go ahead and take out an x in the denominator, take out an x in the numerator, so you would have x to the power of 8 here. Take out y2 here, y2 here, so I have y to the 4 here. Okay, so I'm going to now simplify this. So I can go ahead and break down my radical. I can do square root of 9 times square root of x to the power of 8 times square root of y to the power of 4. Square root of 9 is just 3. And then remember here, this is a square root. So this is, I can rewrite this as x to the power of 8 divided by 2. Okay, Same thing here, there's a square here, so I can write this as 4 divided by 2, keeping with this form right here. So now I can go ahead and simplify the fractions. So 3 is 3. 8 divided by 2 is 4. And then 4 divided by 2 is 2. That's a 4. And that's that. Alright, here, this one. It says, which is not an equivalent. So I could honestly just put all these in Desmos and see which one doesn't equal to each other, and I think that's what I'll do. And then you can stop the video after I finish this, and or you can listen to how I explain it more in detail. But anyway, 27 over 125 to the power of 1 over 3 is equal to that. So I'm just gonna put everything in Desmos and see what all of this is. So cube root of 27 over cube root is down here. I wish there was another way to put cube root in. Maybe there is. If you find out, let me know. So that one's equivalent. Yep, that one's also equivalent. Cube root of 27 over 125. Oops, sorry, that's supposed to be cube root, my bad. 27, just typing. There you go. That was also equivalent. And then the last one. Cube root of 125. And that one's not equivalent. So since it's asking for not equivalent, that's the one that's not equivalent. Alright guys, thank you.